Hello guys, welcome to the demonstration for week 2. This is the R code for predictive model for Los Angeles Dodgers promotions and attendance. Firstly, we include our library car, which is a special function for linear regression, and then library lattice, which is for graphic package. You download your Dodger CSV file and save it under a folder in your computer. You read it by using the read.csv file, and we can check the structure of the data frame here. And then we define an order day of week variable. Then we can do the Explorer data analysis with standard graphics. Attendance by day of week. So we can see Tuesday we have the highest attendance. So we can check it numerically. Tuesday we have the 6, which is the largest number over the week. And then we can define an order of month or variable. The month starts from April and ends by September. Again, this is another analytical data plot for the distribution over different months. It shows the attendance by month. The box plots like this reveal the overall values of data, with the box covering the middle 50% of the data and the center line representing the median. The dotted line or whiskers extend to more extreme value in the distribution. By looking at the box plots, we can make comparisons by day and by month across the distributions of attendance. Now let's move on. We can explore this data further by using a lattice of scatter plot. We map the relationship between temperature and attendance, controlling for time of the game, day or night, and clear or cloudy skies. On day games with clear skies, here, we see what happens to be a moderate inverse relationship between temperature and attendance. So, more telling perhaps are street plots of attendance by a pennant or visiting team. So these are the univariate scatter plots in this figure. Opinions from the large metropolitan areas, the New York Mets, Chicago Cubs, and White Sox, Los Angeles Angels, and Washington, D.C. Nationals are constantly associated with higher attendance. But there were just 17 visiting teams in this study and only 81 games or observations. Accordingly, utilizing the visiting team as a categorical predictor presents problems. Remember last week we talked about the training and test regimen. So here we employ the regimen for model validation by dividing the dataset to two different parts, the training part and the test part. And after that, we can create a model. the attendance associated with the ordered month, ordered day of week, and the bubble head. Then we feed the model to the training set, and then we calculate the predicted attendance by using this model. And then we use the test dataset to calculate the predictions from the model fit to the training dataset. And then we can compute the proportion of response variance. After that, we can merge the data plots, the data points together. So here, that's wrong. We can generalize the linear regression fitted model by dividing the data into the training set and the test set. So here we can find out the linear regression model, the fitted model does a good job of predicting higher attendance at games when the bubble heads are distributed over here. So after that, we can use all available data to fit the model, and then we can test it. So after you fit your model by using all the available data, you can do additional model diagnostics. So this is the suggestions for you guys. You can examine the regression diagnostics for the fitted model, examine other linear predictors or other explanatory variables. See if you can improve upon the model with the variable transformations. This is 4 aspects that you might want to look at. First is the mean of 0. We're going to look at if the residuals spread out evenly around 0. Variance constancy. Check if there is no visible trend on the residual and fitted plot. Independent. If there is no any patterns in the residual and fitted plot. And normality. According to the normality probability plot, you check whether it is distributed normally. So that is pretty much of this code. You can look at the book on the page 25, exhibit 2.1 for the original code. And please run it step by step and understand all the processes over there and finish the suggestions, examination, and try to find other better linear predictors and linear models. Okay, thank you for watching.